Welcome to this channel. In this tutorial, we will design state variable bandpass filter circuit. We will be using LM741 and we will simulate this particular circuit using the Kicad tool. Before going into this tutorial, I request you to like, share and subscribe to my channel below. Now double click on state variable bandpass.schematic file, and now we have to start our circuit design on this schematic window. So click on place symbol, which is on the right hand side of the schematic window. Now place the cursor on the schematic window and type LM741 and select this particular operational amplifier and place this operational amplifier in this schematic window. So for this design we require around 3 operational amplifier, that is LM741. So we would be placing the second operational amplifier on the schematic window. Now right click, select property, edit property, define the reference as U1 and select the aspect as mirror around x-axis and click OK. Similarly, right click and select property, edit property, define the reference as U1 and we have to define the model file for each LM741 symbol. If we don't define the model file or the library file, we will end up getting error when we simulate this particular circuit. Now select the alternate node sequence and define 3, 2, 4 and 6. 3, 2, 7, 4 and 6. Next we have to define the various resistor and the capacitor value. So search for PSpice in the library and select the resistor, place the resistor, right click, select property, edit property, define the reference as R1 and define the value of resistor as 15K and select the orientation as plus 90. Now similarly we have to place the resistor, second resistor value and the capacitor value for this particular circuit design. So place the symbol, resistor symbol on the schematic window, right click, properties, edit property, define the reference as R2 and the value as 511 kilo ohm and select the orientation as plus 90 degree. Now we have to place the third and the fourth resistor in the schematic window. So place the cursor on the schematic window and again you get the library. Select the resistor symbol and place the resistor symbol on the schematic window. Right click, click on properties, edit property, define the reference as R3 and define the value as 15 kilo ohm and click OK. Now again we have to define R4 value. So right click, click on duplicate and place the resistor on the schematic window. Now right click on resistor and click on property, edit property, define the reference as R4 and click OK. So now we have defined our resistor, 4 resistor values. Now we have to place an operational amplifier, third operational amplifier. So place this on the schematic window. Now, in order to rotate this particular op-amp, so what we can do is that right click on the op-amp. We have many hotkeys in Kicad. So you have to click M and R in order to rotate. So now we have to place the resistor R5 and the capacitor C1 in the schematic window. So again, place the cursor on the schematic window and from the library select the resistor and place the resistor. Right click, select property, edit property, define the reference as R5 and the value as 15K. Again, right click, select property, edit property, define the orientation as plus 90. Now we have to place a capacitor. So in order to move a particular component in this schematic window, select that component and just drag that particular component so you can move a particular component. Now click on place symbol and place the cursor on the schematic window and type pspice and select the capacitor symbol. Place this particular capacitor symbol on the schematic window. Go to properties, edit property, define the reference as C1 and define the value of this particular capacitor as 1000 picofarad and select the orientation as plus 90. Now we have to place the resistor number R6 and also the capacitor C2. So place the cursor on the schematic window and select the capacitor. Place the capacitor on the schematic window, go to properties, edit property, define the reference as C2 and define the value as 100 picofarad. Select the orientation as plus 90. Now we have to place the resistor number 6. So place the cursor on the schematic window, select the resistor and place the resistor on the schematic window, right click, properties, edit property, define reference as R6 and the value as 15 kilo ohm and select the orientation as plus 90 and click OK. Now we have to place resistor number 7. We have to follow the similar procedure what we had done before. So define the reference as R7, define the value as 15 kilo ohm and click OK and place this resistor on the schematic window. Now we have to place the final resistor, which is resistor number 8. Place the resistor on the schematic window, click on property, edit property, define the reference as R8 and define the value as 15 kilo ohm and click OK. Now click on place power port. We have to place the ground connections. Before that, we will select the wire and connect the resistor R1 to the first op-amp to the terminal number 3. Now connect the output of op-amp to the resistor number R5 and connect the resistor R3 between the op-amp and the R5. Connect the R3 to R4 resistor and the terminal of first op-amp, that is terminal 2, to the resistor R4 and R3. Connect the resistor R4 to the output of third op-amp and connect the terminal 1 of capacitor C2 to the resistor R4 and the output of op-amp, and the terminal 2 of op-amp 3 to resistor R6 and terminal 3 to resistor R8. Next, connect the capacitor to the terminal 2 of op-amp 3 and connect the resistor 5 to terminal 2 of op-amp 2, and terminal 3 of op-amp is connected to resistor R7. Now the resistor R2 will be connected. So before that, we will just move this particular resistor R2. So to make things easy for us, now again click on wire and connect the resistor R2 to the terminal 3 of op-amp 1 and the capacitor C1 to terminal 2 of op-amp 2, and the resistor R2, the other end of resistor R2, will be connected to the output of second op-amp and the capacitor C1 to the output of second operational amplifier. Now connect the resistor R6 to the output of op-amp 2, and now select the place power port and type ground, select the ground and click OK. Place the ground connection across the resistor R8 and across the resistor R7 place the ground connection. Next, we have to define the voltage source as well as the global label pins. So click on place symbol and place the cursor on the schematic window. Now type pSpice and select voltage source. Place this particular voltage source on the schematic window. Next, click on place label and define this as Vin and place this particular Vin on the schematic window. Click on place power port and place the ground connection and click OK. Now similarly, we have to place the voltage source, that would be VCC and VEE. So click on voltage source and place this voltage source on the schematic window. Similarly, click on ground and place the ground connection and also place the label net VCC. Now place the third voltage source on the schematic window and this would be VEE source. So define the particular label net and the ground connection as shown in this particular tutorial. Now click on wire and make the connections of label net and the ground connections of various voltage source as shown in this particular tutorial. Now right click on voltage source, click on property, edit property, define the reference as VCC, define the value as 0, click on edit property or edit spice model and define the DC as 9 volt. Similarly, right click, select property, edit property, define VEE, define the value as 0 and define the DC value as minus 9 volt and click OK. Also, we have to define our Vin. So similarly, select property, edit property, define the reference as Vin, define the value as 0, click on edit spice model and select sinusoidal, select DC offset as 0, amplitude as 1 volt, frequency as 1 kilohertz and click OK. Next, we have to place the global label pin VCC across all the operational amplifiers terminal number 7 and terminal number 4. So place the global label pin as shown in this particular tutorial and connect all those global label pin using the wire. Now, once we have connected all the global label pins as shown in this particular tutorial, we have to define the model for our LM741 operational amplifier. So what we need to do is that right click on the operational amplifier and click on properties, edit property and click on edit spice model and select the model. So we have to select the LM741 library file. So if we don't select this LM741 library file, we would end up getting error when we try to simulate. Now define the alternate node sequence as 32746 and click OK. Similarly, we have to follow the same procedure for the third operational amplifier. Define reference as U3, select the model, that is LM741 library file, and select the alternate node sequence as 32746 and click OK. So one more thing which I want you guys to remember is when we define the when we want to do the AC analysis, always remember that the AC magnitude has to be 1 volt. So you have to define that AC magnitude as 1 volt for the V input. Now click on place, click on graphic text. Now type .ac decade 100, which is the number of points, and 1 kilohertz and 100 kilohertz, which is the start and the end frequency. Now place this and click on tool, click on simulator, click on run and stop simulation, click on probe, place the probe on the output of the circuit. Now you can see the AC analysis where the magnitude and the phase of this particular circuit. Now you can go and click on add signal, or else what we can do is that we can click on probe and place the probe on the schematic window where we want to do the analysis. So you can see the phase and the magnitude for the state variable bandpass filter circuit. Now consider that we want to do the transient analysis. So go to click on place and define the following text, that is dot tran 4 milli and 8 millisecond and click OK. Now place this on the schematic, click on tools, click on simulator, run the simulation and click on probe and place the probe on the V-in and also place the probe on the output of LM741. Thank you for watching this tutorial. I hope this has helped your learning purpose. I request you to like, share and subscribe my channel below.